All right, we're going to be looking at rate and contextual problems. In all of these, we're given a rate. And before we start talking about rates, let's talk about what a rate is. In all of these problems, there is an amount of something. I'm going to call it an amount. It's how much of something there is. It could be the number of liters of water, how much water there is. The number of pounds of bananas, how many pounds of bananas there are. How many people standing in the line, the amount of people in line. It's always an amount of something. It could be measured in pounds or number or volume, but it's how much of something there is. And then if you do d dt of the amount, this is the derivative of the amount, and it's the rate the amount is changing. And this is what we refer to when we say the rate. This is the rate. How much the amount is changing. So it could be how the number of liters of water is increasing, or how the number of pounds of bananas is decreasing, or how the number of people in line is going up, right? And often there are two rates. There's a rate that something is increasing. I'm going to write rate of increasing, and a rate of decreasing. Okay, so we're going to pay attention to this as we look at the next few problems. Okay, so here are the most recent three, or three of the most recent ones, depending on what year you're viewing this in. In 2015, there was rainwater flowing into a drain pipe. And so the amount here is how much water there is in the drain pipe. The rate is so there's two rates. The rate of increasing, the rate that the water is flowing into the drain pipe, tells you how much water is adding in, is measured in cubic feet per hour. And you'll always see that rates are in an amount, cubic feet per time. So it's an amount per time are the units. And this is the rate of increasing. And they also give you a second rate. It is the rate that is draining out of the other end. This is the rate that is the amount of water is decreasing. Okay, great. Let's look in 2017 how this looked. There was a grocery store, and it's about bananas, how many bananas are on display. And it tells you how quickly customers are removing the bananas. So this is the rate that it's decreasing. And then the employees in the store start filling back up the bananas. So this is, of course, the rate that the number of pounds of bananas is increasing. In 2018, they gave us, this is about people in line for an escalator. That would be the amount of people in line. And then the rate that the number of people are getting into the line, entering the line, that's how much the rate is changing, is measured in people per second. And this is the rate of increasing. And they give us a second thing, that they're exiting the line at a constant rate. So the rate that it's decreasing is a constant of 0.7. Okay, so now that we see what the rates are and what the amounts are, let's start looking at some questions. And the first question we're going to look at is the overall, so I'm going to put this at the bottom here, is the overall amount, you guys can't see this, is the overall amount increasing or decreasing? Okay, and this comes up in 2015 in part B. Is the amount of water in the pipe increasing or decreasing at time equals 3 hours? Well, to do this, we just need to compare the rates. The rate that it is increasing at time equals 3 is R of 3, and we would type this into our calculator. We would just put in 3 for t. And the rate that it is decreasing at time equals 3 is d of 3. And we would compare this. If it's increasing more than it's decreasing, then the overall amount of water in the pipe is increasing. If it's decreasing faster than it's increasing, then the amount of water in the pipe is decreasing. And this should make sense. And the reason we would give is we would find these values and say, the water in the pipe is decreasing at time equals 3 because d of 3 is greater than r of 3, or vice versa. I'm not going to do any of these things on the calculator. You can do those on your own. It came up in 2017 in part C. Is the number of pounds of bananas increasing or decreasing at time t equals 5? So of course, you want to think to yourself, is it increasing more or decreasing more at t equals 5? So the rate it's increasing is g of 5. And the rate it's decreasing is f of 5. And we would compare those two numbers and see which one is greater and give our reason. Okay, The next common question is the meaning of the derivative of the rate. So if we have a rate, an overall rate, I'm going to call it rate overall, and they want the derivative of it, or maybe it's just a rate, and they want the derivative of it. What does that mean, and what are the units? This comes up in 2017, part B. It says find f prime of 7. So it's the derivative of this. Remember, this already is the rate of change of the, it's how the bananas are, it's the rate that the bananas are decreasing. So if we take the derivative of it, it's going to be the rate of change of the rate of change. The derivative tells us the rate of change. So it's the rate that the rate, let's see what rate we're actually talking about here. It's the rate that the rate customers remove bananas is changing in, and we need to find f prime of 7. Here we would just plug this into our calculator and see what the derivative is. You can use the derivative button on your calculator to find it. It's the rate that the rate is changing at t equals, when it says units, we need units for every number, so we need units for this 7, and that's a time, and it's measured in hours. And we would say changing, and we would want to know if it's increasing or decreasing. If this derivative is positive, the rate of the rate is positive, so the rate would be increasing, is changing at t equals 7 hours in, and the units are going to be the units of the rate, which is pounds per hour per hour. So pounds per hour squared. Yuck. Okay. So after this, we'll get to the other major important question that comes up every time, which is they ask about the amount. So we can, remember we were talking about rates and amounts, and there's a connection between these two, and it's the fundamental theorem of calculus. Remember that the rate is the derivative of the amount, and so the integral of the rate from a to b is the amount at b minus the amount at a. Remember that the fundamental theorem of calculus tells us we can do the integral of a derivative, and it'll tell us how much the amount changed by. And so we're going to use this a lot in these problems. Let's look at part A in all three of these problems. How many cubic feet of rainwater flowed into the pipe? Well, that's how much water got added over the course of 8 hours, and this is a direct application of the fundamental theorem of calculus. It's going to be, I call this question the amount of increase and decrease over a certain time. And of course, it's going to be the integral of the rate of increasing, right? Because it's how much it flowed in. In this case, that is r of t, from 0 to 8. And you just find that number, and that is the amount. You need to say the integral, and the answer, you just type it into your calculator, it gives the answer. Okay. Part B, how many pounds of bananas were removed from the display during the first 2 hours? So removed from, this is going to be the rate of decreasing, that's f of t. And what was the amount that was removed? That's going to be the integral of the rate, the integral from 0 to 2 of f of t dt. And you just find that number. You type it into your calculator. It's super straightforward. In 2018, how many people enter the line between 0 and 300? Well, here's the rate people are entering line. And so the amount is going to be the integral from 0 to 300 of r of t. That's it. Whatever that number is our answer. Great. The next question is the amount of time, the amount at a certain time. So this is slightly different than the amount it increased by. So the amount it changed by is directly fundamental theorem of calculus. Remember, we can rearrange the fundamental theorem of calculus and say if we know the amount it started with, so amount A at time A, we can add in the integral. So we're just basically moving this over to the other side. We can add in the integral from A to B of the rate, and that will give us the amount at a time B. And usually this is going to be in the past, this has been total amount, and so we're going to have to use both the rate that something's increasing and the rate that something's decreasing. Let's look where this comes up. In 2015, this kind of question comes up at in question number B. Question number, it didn't come up in 2015, sorry. 2017, it came up in question D. Great. How many pounds of banana are on display at time equals 8? Well, we need a starting amount, and it always gives us that starting amount. There were 50 pounds to begin with. That's the starting amount at t equals 0. And we're going to do plus the integral from 0 to 8 of how much did it increase. So that's f of t dt. We need this dt here. Minus how much it decreased by. So that's going to be the change. So 0 to 8 of g of t dt. And this is the fundamental theorem of calculus, right? How much we started with plus how much we increased by minus how much we decreased by will give us the final amount of bananas. And I think I'll do one more here. This was in 2018. It asked us how many people are there in line at t equals 300. Well, it's going to be the total number of people we started with, which was 20 people in line, plus the integral from 0 to 300 of the amount it's increasing by, minus the integral from 0 to 300 of how much it's decreasing by, which is just a constant of 0.7. Cool. I'm going to stop this here. I'm going to make a second part of this video.